Hi. Scopes form one of the omnipresent concepts in the programming languages. Even if you write one single line of code, scopes come into play. Well, the other aspect of scopes is that scopes, specifically the lexical scope, forms the foundation upon which the entire concept of closures in JavaScript is formed. I'll dedicate another video which will be focusing entirely on the concept of the closures. In this video, however, I'm going to focus on scopes as a standalone concept. We'll do this through the lens of the where keyword and the let keyword. We'll see how the usage of where versus the let during the declaration of a variable dictates the way in which the variable is accessible from other parts of the code. Of course, we are going to see the parts, the concepts in scope, which form the segue to the concept of closures. So let's get started. So let's check this code where we have a function foo here, and inside function foo, there is another scope created with if. The function foo scope has a variable a and the if block has a variable b. Now, what does the rule of scope says? The rule says that any variable is accessible from its own scope plus from anywhere inside its inner scopes. However, it's not accessible from anywhere outside its scope. That means the variable a will be accessible from its own scope plus any scope that lies inside its scope, which means this if block in this case. However, it won't be accessible from anywhere outside its function scope. Similarly, variable b will be accessible from this block and any inner scope in case if block had any inner scope. However, in this case also, variable b will not be accessible from anywhere outside its own scope, which is the function scope. In this case, function scope foo will not be able to access b. So, for these two sets of line, console.log, one set lies inside the if block and the other set lies in the function scope, and both are trying to access the variables a and b. So, for these two lines, it will be able to easily access b because it lies in its own scope. In addition, it will also be able to access a because the if block lies inside of a's scope, inside of the function scope. Again, now coming to the outside of the if block, it will be able to access a easily this time because it lies inside the function scope itself. However, it won't be able to access variable b because we are trying to access b from a place which lies outside b's scope. So, essentially, these two lines should be able to access both a and b, but in these two lines, only a will be accessible while b is not because this lies outside the scope. Let's see. Contrary to the rules, we see that all the four lines of console.log, both inside the if block and outside the if block, that is the function block, is able to access the value of a and b. So what is the explanation for this behavior? The explanation lies in the usage of the where keyword. There is a slight exception when we declare a variable using the where keyword. One part stays the same though. The part that stays the same is the part where we say that a variable is accessible from anywhere inside its own block plus its inner block. The part where it differs is where the original rule said that from the outside blocks, a variable will not be accessible. In case of the where keyword, there is a slight exception. The exception is that for the outer blocks from where supposedly a variable is not accessible, there is an exception made for the outer block, which lies immediately outside its own block. Which means for variable b, the immediately outside block is this function block. So only for this outside block alone, only for the immediately enclosing block alone, a variable is accessible, provided you declare that variable with the where keyword. That explains the accessibility of b even from this line number 9, because we are trying to access the value of variable b from the immediately enclosing block of the if block, which is the function block.
Okay, so far so good. But how do we achieve what we're trying to achieve in the first place? That variable b should not be accessible from anywhere outside its own block. Of course, it should be accessible from the inner blocks. The answer to this lies in the usage of the let keyword instead of the where. The let keyword actually sticks to the original rules of the scope that I had stated in the starting of this video, which says that a variable will be accessible from its own scope plus the inner scopes, but not from any of the outside scopes, not even the immediately enclosing block. This is what the second code snippet is about. Let me comment the first part. The second snippet is exactly the same as the first block, as the first code snippet. So here also there is a function scope with its variable a, and then there is a if block with its variable b. And we are trying to log the outputs in both the if block and the function block. The only difference is that here the variable b is declared with the let keyword, not where, which will ensure that it's not accessible from anywhere outside its if block. So ideally, line number 23 should throw a reference error. The rest 3 lines should be able to print it because they are accessible going by the rules. Let's see. The first 3 lines are able to print because they are accessible. Line number 23, like we expected, is showing a reference error this time. And it's serving our purpose. Because this time we declared variable b with a let keyword, not where. So that's where the let keyword comes in handy. If we want to limit the accessibility of a variable to only its own scope and of course the inner blocks, but we want to restrict its access from all its outside blocks, all its surrounding blocks, we would use the let keyword instead of where. This difference between the where and the let keyword, apart from the obvious places like the blocks, carry over to the other programming constructs as well, almost any programming construct. For this example, we'll use a loop, the for loop. In the first example, we have a function foo again, where inside the function foo, we have a for loop constructed. Note that this variable I is constructed specifically for the usage inside the for loop. But unfortunately, we are declaring it with the where keyword. That's why, as per the previous rule, the access of the variable I will spill over to the immediately enclosing scope, which in this case is the function scope. That's why in this line number 5, even when the loop has completed its run, and yet we are trying to access the variable I from outside the for block, it's still accessible. But if we declare the same thing using the let keyword like this and run it, inside it's able to access as expected, but also as soon as we are trying to access outside the for block from the function scope, a reference error is thrown. Note that this variable let allows us to freshly rebind the value of I to the value of its snapshot, which is 0 or 1 in this case, at that point in time, at that point in the iteration. This fact that there is a fresh binding at every iteration of the loop finds its usage in Clojure, which we'll see in depth in another video. How does the hoisting play out in case of the variables declared with let? Well, unfortunately, hoisting does not happen for the variables declared with let. I have covered hoisting in depth in another video, but in summary, the hoisting rule says that whenever there is a variable declaration, or it might even be combined with the assignment part, even then, the variable declaration part is raised to the top of its own scope, meaning it will be something like this. The declaration will be raised, keeping the assignment the same, at the same place. So, when we are trying to log the value of A to the console, it will not compare that it's unable to find A. Of course, it will be an undefined value, but it will not show a reference error in case the variable is declared with the where keyword. So, if I run this, it says that A is undefined, and rightly so, but it doesn't show a reference error because hoisting is happening for the where declarations. But if we declare with let, the hoisting will not happen, meaning this thing will not happen. So, it will stay how it originally was. So, at the point where we are logging the value of A to the console, there is no A that exists at this point. So, it will throw a reference error. Like you can see here. So, the point to note is that despite its advantages, the variables that are declared with let keyword cannot have hoisting. So, it's the responsibility of the developer to ensure that the declarations and the usage follow the correct order. Then there are the explicit blocks. That means a scope doesn't necessarily always have to be a function block or an if block and so on. We can create scopes. We can create explicit blocks wherever and whenever we want to, provided that we don't really compromise on clean code. So here, there is this function scope where we have a variable A and then we log the line. But for some reason, if we want to demarcate this part within the function scope also, we can do that by creating an explicit block, like you see this pink pair of braces here. And then, of course, declaring the variable with let. That will ensure that anything outside its explicitly created block is not able to access the variable A. So here, this line will be throwing a reference error. That's about the explicit block. You would be declaring a variable with the let keyword and then creating an explicit block with the help of a pair of curly braces.
Then comes the lexical scope. Lexical scope is pretty much everything that we have been discussing till this point. Lexical scope is defined at the point of writing the code, and this author time scope stays as it is. Lexical scope forms the starting point for the entire concept of JavaScript closures that we'll see in another video. Yeah, that's pretty much what I wanted to cover in this video. We started with seeing the usage of the where keyword, but counterintuitively, a variable declared with the where keyword is attached even to its immediately enclosing scope. This is where the usage of the let variable comes in. But then again, let has its own limitations, like we saw. A variable declared with let keyword is not hoisted. So at the end of the day, it calls upon the judiciousness of the developer writing the code. In the next video, I'll cover the concept of JavaScript closures in detail. building upon the concept of lexical scope that I had introduced in this video. Thank you so much for watching this.